Hello friend, this is the first video on thermodynamics. Today we are going to learn about its third law. Before that, let us know what is thermodynamics. Thermodynamics is divided into two parts, that is thermo, which means energy, and dynamics, which means transformation. Now let's begin. Third law of thermodynamics. This law is also known as Nernst's statement, as it was discovered by chemist Walter Nernst. It states that entropy of any pure crystalline matters or substance at absolute zero will be equal to zero. For better understanding of this statement, let us have a short description about three major factors on which this law is based on. The first one is entropy. It is defined as the randomness or disorder of the molecules of a system. Let us consider a cylindrical vessel filled with water and a solid object. As there is always thermal energy present in nature, this energy always continues to energize the molecule of the system, like the systems of water enclosed in vessels, solid object, or even a gas filled in balloon. These molecules are always in motion at or from their mean position. This phenomenon is termed as entropy. And the second part is perfect crystalline substance. It is defined as the molecules of this substance which are of same size and are arranged in perfect orders. And now the most important factor influencing this law is absolute zero. Now it is defined as the lowest possible temperature where nothing can be colder than this. It is also known as 0 Kelvin. Now let us know how this law violates the natural phenomenon of energy or entropy of any systems. So in reality, there is no presence of perfect crystalline matters or substance. Even the crystal of CO, N2O, H2O, etc. are found with imperfection, as there always exist any impurities, vacancies, or interstitials. Such defects, disorder arrangement are usually caused due to presence of residual thermal energy, which then simultaneously create very minimum moment of particles, leading entropy not to be zero. Moreover, even according to second law of thermodynamics, entropy of universe always keep on increasing, it never decreases. Now, highlighting the condition of molecules on absolute zero, let us consider with an closed glass vessels filled with gases placed in atmospheric temperature. The molecules of gases are in random motion as shown in stage 1, and now as we decrease the temperature by any mean, the molecular motion becomes less, as we can see on stage 2. And as we keep on further decreasing the temperature till 0 Kelvin or minus 273.15 degrees Celsius, all the gas molecules comes close to each other with zero motions and behave as solid matters. It happens so because the internal energy, which is in form of rotational energy, vibrational energy, or translational energy, comes at zero state. Overall, we can say kinetic energy of molecules become zero. That also signifies decrease in entropy to zero, as entropy is directly proportional to temperature. But surprisingly, even the absolute temperature doesn't exist in real. Due to this, there is always some existence of thermal energy. However, from this law, we can conclude that the lowest possible or zero value of entropy can only occur in pure crystalline substance at absolute zero. For your knowledge, even this is not possible in practical. So the question is, what's the benefit of this hypothetical law? Well, this law provides absolute reference point for the determination of entropy of any substance at any given temperature. The absolute entropy of any system at zero temperature is the natural log of the number of possible microstate time Boltzmann constant. It is given below. Now, let us discuss the second part of this law, which is known as microstate. It is the instantaneous and specific configuration of all the particles of a system which determine the instantaneous velocity and position of molecules. Microstates are only the reason for spontaneous increase of entropy when any heat energy is provided. To increase this instantaneous property, it is necessary to increase either of the two factors, that is volume or temperature. Let us assume there is increase of heat energy in a system that causes the volume to increases. Consider the volume to be double. Let us assume initially there are 4 particles, or we can even call it as 4 atoms or molecules, say red, green, blue, yellow, at one microstate represented by symbol number A. As we increase the system volume to double, the possibility or the probability of distribution of the particles from state 1 to other state can be up to 16. We could have either any one of the 4 particles in empty space, another 3 in one. We could have 2 equally in both the space, or 3 in one, or we could have 4 in one. So these are the number of microstate that any number of particles can attain in a system when the volume or temperature is increased. This process of forming or dispersing of particles increases, and simultaneously we can say that there is a spontaneous increase of entropy. Now you can have a formula for calculating the number of microstates. So this is the end of my video. Hope you all understand. Please do like and subscribe my channel.